Hello, good afternoon, and welcome to this webinar. My name is Marco De Biasio, and I'm product owner at SCIA. And today I'm going to introduce you the new Eurocode 3D wind load engine that has been introduced in SCIA 22. In this webinar that will have the duration of about 20 to 30 minutes, we are going to see all the novelties concerning this new development, and in particular we are going to see firstly the novelties concerning the transparency of the use of the wind load engine. They have been introduced this year, the possibility to visualize pressure and suction zones, the possibility to visualize net wind pressure, also the possibility to visualize the peak velocity pressure. Then we are going to see how to use the new 3D wind load engine on buildings with openings, then how to use it on awnings, and finally how to use the wind load engine on canopy roofs. I'm going to use directly the software, then I will not use slide, if not just to sum up the things that we are going to see, and the demo will be done all on SCIA Engineer. Let's start opening the software. Okay, I prepared several models for this webinar. Let's start with this one, that it's a simple frame structure that has been enveloped by load panels, as you can see here highlighted in red. And the first thing I want to show you is how the visualization of the applied wind load is changed. Uh, to do this, let's go to generate wind load on this load panels. Then I will go to activate the 3D wind load generator. I will add the load cases. There is no need for the purpose of this webinar to have all the possible combination of pressure coefficient. Then for simplicity, I remove and I just keep 4 load cases corresponding to wind from 4 directions. Okay, I generate the load, and till now everything is like in the previous version. But now if I go to visualize the load, for instance the one on direction 0, then that correspond to the direction plus x global coordinate, then the red arrow here, what will happen is that, as you can see, you will see the wind load now generated in two colors. Before everything was blue, then it was impossible to distinguish between the zone where there was pressure and the zone where there was suction. Now this distinction is much easier. As you can see, the blue corresponds to the pressure. Here you see if the load case 0, then the wind load arrive in this direction. It push on this face, and the other on the other faces of the building, because of the combination of plus of the exterior and interior pressure coefficient, you have aspiration everywhere. Of course, if I go to see the opposite direction, then the minus 180 degrees, I will have this time pressure in this side and aspiration on all the other, and so on for the other direction, for instance 90 degree. Then, as you can see, now it's much easier to check what the wind load generator does. Before everything was equal, then even for a control office or for yourself to check if the wind load generator did a good job was really difficult to check. Now it's really with a glance, you just see, and you can see if you notice something strange. Then I think that this is really a nice development. Concerning the colors that have been chosen, here by default we have this light blue for pressure and this yellow for suction. Of course, we tried to choose some colors that was not too heavy and then covering the model, but if you want to change because you prefer other colors, you can do it, of course. To do this, you have to go to the menu view, colors and lines, and you can here find wind load pressure and wind load suction. Then, for instance, if I want to change the color of suction from yellow to, let's say, pink, I can just do it here. And that's in such a way you can quickly configure the colors as you want. Then I put back the yellow just because I like it, and I will continue. Other things that have been introduced in version 22 is the possibility to have an information on the used net pressure and also on the used peak velocity pressure. And to do this, simply right click and settings of the view, and here, if you go on the part relative to load and masses, you can find under the labels of wind data, as before, of course, the possibility to visualize the pressure coefficient, but now you can also visualize the net pressure and the peak pressure. For instance, if I select net pressure and I select, of course, also display labels, you can see that the value of net wind pressure are now shown in each wind zone. Then like this you can quickly check which value have been used for the computation in each zone. Mm. And the same, of course, you can do for the peak velocity pressure. Then again, it's the same procedure. Then view setting for all entity, and here I can deactivate the net pressure and I enable peak pressure. And in this case, I have the value of peak velocity pressure that has been used for the computation. And another thing also that is possible to do, if I go back to the settings, is to visualize the net pressure not via labels, but just with, yes, other labels, but associated to the arrows. Then to do this, simply I can say display the value of the loads under the labels of loads, not the labels of wind data. And doing it like this, you can see that for each set of arrow, we can see then for each load applied to a wind zone, you will have the relative value of the net pressure that has been used. Then this can be also something nice for you if you want to check the wind load that has been applied. Of course, as you can see here with these colors that are quite light, so it can be a bit difficult to see the numerical value. But of course, if you change colors because you prefer this way to represent the net pressure, you can choose something a bit darker, and then you will have a clearer visualization of the net wind pressure. But again, it's another way that you can use to check that the value that have been used in the computation are the correct one. Then the aim, in fact, of this implementation, this new implementation, is really to give transparency to what the black box that is the wind load generator does. Okay, said this, let's move to the next part, in which I want to show another important novelty, that is the possibility to correctly compute wind load on structure with openings. Before doing this, let me just remove these labels for simplicity. And now, for instance, let's say, okay, I have this building that has been computed as a building with no openings. What if I have an opening on a side? Simply, what can I do in this case are two things. I can say that I have an opening on the face, and I can do this without to have physically the opening on the structure, or I can also model an opening on a face. I can do both cases in this case. Let's say I go to structure and I go to look for openings on load panels, and I will create an opening on these load panels. Okay, and then just a rectangle like this, for instance. Okay, and I can create also another here. Why not? In fact, you can do as you prefer. Okay, I can say again, and here I will create kind of door like this. Now here there are two openings, and to do the other example, I will say, okay, I consider that also this part, in this part there is an opening, but I don't want to create it like physically on this load panel. The only things that I need to do to tell the software that I am using opening, then it means that when the software goes to compute the internal pressure coefficient, it has to take into account this, is just to act on the wind data. Then, for instance, I select this panel. I've associated to this panel the wind data. Here, it recognized automatically that there is type wall. And as you can see now, the novelties, there is this setup for the openings. I just switch this on. And what I have to say is just the amount of area, then how much is the surface. Here, let me switch the units to meter, make more sense. And also I have to say if the face is dominant or not. Dominant as defined in the Eurocode. As you can see, currently it doesn't compute automatically the opening based on the physical opening that I inputted. This will be implemented quickly, but for the moment we have to input the surface of the opening. For instance, let's say this is 5 meters square. And 5, okay. And the same I can do on a face where, for instance, there is not opening at all, like this one. There is not a physical opening. I set the wind data. Okay, I say there is an opening. I say it's dominant face. And I say, for instance, let's say 20 square meter. What is going to change now with respect to before? If we go in the help, all this new development have been documented. And if you go in the part relative to 3D wind openings, you will find a bit apart the procedure to enable this new functionality. You will find the explication of what is in fact done. There are 3 cases, in fact. The first is what corresponds to what was happening before. Then there are not opening at all in the building envelope. Then the procedure will be exactly as it was in previous version of SCIA. If there are opening, there are 2 cases. There are opening in the building envelope, but no face is set as dominant. And in that case, then the procedure described in this chapter of Eurocode is applied, then based on the value of the opening, the internal pressure coefficient is used. And in the same way, if you have a face set as dominant, the rule of Eurocode are used again to correctly compute the internal pressure coefficient. Then I invite you to have a look at this web page because everything is explained, and as you will find, everything is done according to Eurocode. Then again, here I have defined my openings. Simply, if I want to compute the wind load, again, I go to load, 3D wind load generator. I do run generator, and different from before, before you would have had a warning message saying I would have computed the building like without opening. Now the building is correctly computed. As you can see, the pressure distribution changed because of course the internal pressure coefficient is different. It's not anymore the same based on the openings. And as you can expect now, many possibilities open for you to model a building because you don't need to do manual things to adapt the internal coefficient of pressure. It's automatically done by the software and based on the opening that you input on your model. I think also again it's a very new nice development for many of you. Okay, said this, let's move to the next. And before to do this, again, going to the help, I just want to show you that also what I first shown then was the part relative to the colors. It's documented, then the new visualization. You can find explication of the new wind pressure visualization again on this help. I insist a bit on this because these web pages have been totally redone. Then you will find a lot of information here that can be very useful. But okay, let's move again to SCIA and let's talk now about awnings, how to generate wind load on awnings. To do this, let me disable the visualization and let me create an awning in order to do the example. I will go here, for instance, and structure. I can create a plate. Let's say I will do here, on this other face. Then I do something rectangular here. Oops, I didn't do correctly. I do again, plate. Okay. Here. Okay, something like this, for instance. I just will move it in vertical direction, then from here to here. Okay, I select it and I say I want to use 3D wind load engine on it. To specify that it's an awning, what I can do, simply go to wind data. I selected it as a roof. I say no, it's not a roof, for me it's an awning. It's done. What happens now? Simply, if I go again to the wind load generator without to do anything new, I click wind load generator. Wind calculation is finished. As you can see, the wind load has been generated again on this awning, and it has been correctly generated based on the wind zone according to the normative. You can also see it here in an easier way. And you can have as many awnings as you want in the building. The dimension should be, of course, according to the normative. And this again, it's a nice novelty and allow you to model quicker many more buildings with respect to before. What should be said on the awnings is this. If I go back now to the PowerPoint, this is the part on the transparency, the openings. On the awnings, the particularity is that they are not covered by the base document of Eurocode. It means that there is nothing in the Eurocode 1991 4 on the wind load on awnings. How to generate wind load on awnings is specified in the German National Annex of Eurocode, then the German National Annex 5. It's specified in a document of French norm by CTCM, and is specified also on a document in United Kingdom, then this PD 6688. For all other countries, there is not specification of how to generate wind load on awnings. Then what happens in SCIA Engineer? If you are using Eurocode with national annex of one of these three countries, then Germany, France, or United Kingdom, you will have, of course, the respective normative, then way to apply wind load on awnings, it's used. Then if you are in Germany, you can use this. If you are in France, you can use this one. If you are in UK, you can use this one. If you are in another country, we give anyway the possibility to use the wind load generator on the awnings, but on this, for all the other country, is the German national annex that it's used for the generation on the awnings, just on this. That it means that the wind zone will be generated accordingly to this. Also, for instance, if you are simulating wind load in Belgium or in Czech Republic, just to do two examples. For all the other, of course, because there is a norms, then a guideline, that guideline is used. For the countries where this guideline is not used, we give anyway the possibility to choose to use this wind load generator. But of course, if you don't want, because you are, I don't know, in Austria, you don't want to use the German one, you can apply by manually the wind load on the awnings. Okay, said this, let's move to next part, that is wind load on canopy roof, then on isolated roof. I will move to the other model that I prepared for this. And as you can see, now I have a totally different structure, and it's just, as you can see, some columns and a roof. Then this canopy roof with two pans. It's kind of structure in which, with previous version of SCIA Engineer, was not thinkable to apply the wind load generator, but as you will see now, it's a new possibility that has been introduced. Then what happens if I want to generate wind load on this structure? Simply, as usual, I have load panels that I used on this, but I could have used also finite elements, would have been the same. Let me just select the panels here, and of course, once this is selected, I say I want to use wind load on these panels. I move to wind data that are automatically created once I switch on this setting. And now you can see it recognized then as a roof, but it's not classical roof, it's rather a canopy. Then I switch to canopy. Now I have to select which kind of canopy is, if it's mono pitch or two pitch, then or flat. In this case, it's a two pitch because, as you can see, you have the two part. If I would have had just one, would have been a mono pitch. And of course, I should have to specify which is the blockage ratio that I have on this canopy roof, as according to the Eurocode. As you know, the blockage ratio specify the amount of, let's say, stuff that are under this roof, then can block the flux of wind. For the moment, I leave 0. It's not important. You will decide based on your project and your design situation. But simply, I do this. And now I go to generate the wind load. Say, add load cases. OK. Run the generator. And it's done. As you can see, no a warning message like in the past, no error. The wind load is generated. And if I can go to see it, it's exactly like before. I can have the visualization of the wind load on the several zones. Yeah? And as you can see, the wind zone are respected. If you are practical with the wind on canopy, you will recognize, in fact, the distribution of loads on this structure, and that make I think your life for this kind of structure much easier, because you don't have to input manually the wind load, but simply you have the wind load generator. Of course, the wind load will change accordingly if you have different geometry. For instance, let me just make an example. If I have this and I select this node that are coordinate 5, I put, let's say, 4. Let's say something less, 2.5. Okay. I want to change the wind load. Simply run generator again, and it's adapted. Then the wind load and the associated wind coefficient is totally adapted really quickly. Again, this is something new, and we hope that the people that do this kind of structure that are very common for people that use steel, timber, and so on, we hope that this will simplify a lot your life. And again, also for this part, there is a new documentation on the help online that I invite you to have a look at this. As you can see, there is explicated everything that has been introduced, and then the reference to the chapter of the normative that have been used, how to input the wind load, and the reference also you can see for inputting the blockage ratio. You can see if there are obstacles that block the flux of wind or not. Then in this case, when there are a lot of obstacles, maximum value of blockage ratio equal to 1. When the flux is free, it's the opposite situation, then the value is 0, and between the two you can choose the value of blockage ratio between 0 and 1. And again, how the wind load is generated according to the Eurocode. You will find everything here. The same also for the awnings, as I was explaining before. Here you will see apart the procedure that has been used, the specificity for the different country, then for the German national annex and for the French guidelines and for the British guidelines. And of course, remember that if you don't are in one of these three cases, the German national annex will be applied. Then to sum up, this year in SCIA have been introduced many novelties concerning the 3D wind load engine. They have been asked for since long time, and we hope you are going to enjoy their use. I see that the time for this webinar is close to the end. It's not an issue because we have done, I think, everything I want to say you has been said. With this, what can I see is that there are some question. I will reply to this now after the end of the webinar via email. I thank you for your participation to this webinar, and I invite you again to have a look at the documentation. And of course, if you have a doubt or question, you can always go toward the support of the engineer to inquire on this new developments. Then thank you again for your participation to the webinar, and have a nice end of afternoon. Bye.